Good morning. Today we'll discuss about the convolution code. Cyclic code and block code belongs to block code category. In such code, data is encoded in blocks. It consists of data and check bit both. Encoded message is the combination of data and check bits. Convolution code generate encoded sequence by input sequence on bit by bit basis. The work on input bit rather than block of input sequence. Convolution code can be understood in transform domain and time domain also. They are decoded with the help of maximum likelihood algorithm like Bertby algorithm. It is very important algorithm. So we first discuss basic concept convolution code, and this is the basic concept of block diagram or convolution code. uh, we have three messages like m1 and m2, but m1 is the message for bit input only. This bit represent current message bit. This bit is a part of shift, and m2 and m1 bit is previous to successive message bits are stored in those two fifths of those bit m1 m2 represent state of shift register, and x1 and x2 is the output of two mode adder, and output connected by switches 1 or 2. Here k is equal to 1 means m, and n is equal to 2 means m1 and m2. Total convolution code k is equal to 3. A convolution coding is done by combine the fixed number of input bits. The input bits are stored in fixed length shift register, and they are connected with the help of mode 2 adder. This operation is equivalent to binary convolution, hence it is called convolution code. And operation: whenever the message bit shifted to position m, the new value of x1 and x2 are generated depend upon the m1 and m2. m1 and m2 store the previous two message bit. The current bit is present in m, so we can write this x1 is equal to m plus m1 plus m2. It is mode 2 adder, and x2 is equal to m1 m plus m2 mode 2 adder. x1 is the combination of m1 and m2, and x2 is combination of m and only n2, not m1. So the output switch first sample x1 and then x2. The shift register then shifted contains of m1 to m2 and contains of m to m1. Next input bit is be taken and stored in m. Again x1 and x2 are generated according to new combination of m1 and m2. The output switch then sample x then x2. Thus the output bit stream for successive input bit will be x is equal to x1 then x2 again x1 x2 again x1 x2 so on. So number of message bit k is equal to 1, and number of encoded output bit for one message bit n is equal to 2. And some basic terms for convolution code is code rate. It is equal to r, and it is again equal to k upon n, almost 1 upon 2 in this case. Second thing is constant length is k, means k is 3, and dimension of code n and k N is encoded output bit for one message bit, and K is number of message bit taken at the time by encoder. And we use two approaches for analysis. The convolution code is first is time domain and second is transform domain analysis. But in time domain approach, we have again two methods: convolution method and matrix method. First thing, convolution method. It is very important. Let's sequence we have here is Z01, Z11, Z21 for one output, and again is for x2 is Z02, G12, G2, so on, and we can express the sequence x1 is xi for 1 is the summation of g1 mi minus 1, and here I is equal to 0 1 2 3 4 so on, and again x2 is xi for 2 is summation of g L1 m I minus 1, again I is equal to 0 1 2 3. So output sequence generated is xi is x01, x02, again x11, x12, and x21 and x22, and again this sequence is continue, and always xi14 is x01 x1 for one conditions. Then again next method is we use matrix method. It is useful for short length of input message sequence. Output of convolution encoder can be calculated using matrix method. We use the net matrix gi1 for g1, g21 and so on, and gm for again 1, and gi2 for and g1, g2 2, and g3 for again 2, so on. And generator matrix contain L row and n multiplied by L plus 1 minus m minus 1, it is column, and we get output of we can generate the output of convolution encoder is last cyclic code method x is equal to mg is m, again here is message sequence represent the matrix m1 m2 m3 m4 and up to ml. L is the length of message. Transpose to analysis to convolution encoder, impulse response be present by polynomial, and again is g1 for p is the polynomial, and z0 for 1 z1 for 1 and multiply by p plus g2 for 1 and p square, and it goes to gm for 1 and p power of m, and again g2 generate matrix generate is g2 is z0 2 plus g1 2 and multiply by p plus g2 2 p square and so on gm for 2 and pm. The variable p is unit delay operator in above equation, and convolution sum are converted to polynomial multiplication is transform domain x for 1 p is again gp for 1 and multiply by mp in a message polynomial, and xp for 2 and gp for 2 and again multiply by mp, and mp is message polynomial, it is as used as cyclic code, and mp is equal to m0 plus m1 multiply by p plus m2 p square and up to m base l minus 1 and p power of l minus 1. L is again length of sequence message sequence. Then thank you.